Hello everyone, welcome to 1.2.1 of CodeHS AP Computer Science A 2025. We're going to be talking about variables and primitive data types. So computers can analyze and do all sorts of things. In programming, a variable is a storage location that holds a value. Okay, these values have to be stored on the computer. And so each variable has a unique label called a variable name, and they store specific things. An amount might store 60, a value named color might store the color blue, and is sunny, a Boolean value, would store a true or a false value, but in this case true. So each of these has a data type. So a variable's data type specifies two things: the type of information that a variable can store and what you can do with that information. So now the computer knows what we can do with an int, a number. We can add it and do arithmetic. We can multiply, divide, subtract, and do modulus, which we'll learn about later. So what are the different data types? There's primitive data types that just store a value. And then there's reference data types, which references a location in data that allows us to store multiple values within that single variable. So we're still going to start with the primitive type. It's the most basic, fundamental data type. And represents the simplest building block of data. So the primitive types that we're going to use in this course: int, double, Boolean, char, and these are the most commonly used in Java programming. And so an int value can be positive or negative. There is a limit, but it does the job of counting, as you might expect. Or simple integer arithmetic. So there's also double value, which is usually used with measurements or money, the cost of a value. So a lot of times in science, or utilizing it with money. So a Boolean value is true or false. So is the cat asleep? True. Or false, the cat is not asleep. Okay. Char or char value, short for character, is an individual character. Now we don't really use those values, this data type, very much. More often they're merged together and used as a string value, which we'll talk about a little bit later. Okay, and they use single quotes in order to identify. Okay. So declaring a variable is just giving the computer a way to identify what the name of whatever you're creating is. So we are creating a name of a variable called numcats, and it has a type of int. So it's different than some other programming languages. Java, you need to be very specific and identify exactly what variable data type you are using. Okay, so numcats is the name of the variable. It's of int type, but we have not given it a value yet. Now, in some cases, like in the main method, this would cause an error if we tried to utilize numcats. But in other classes, which we'll talk about later, that is appropriate to not give numcats a value and sometimes get set to a default value. But there are different rules for that depending on where it's being utilized. So naming guidelines, numcats, you want to be descriptive. So you want to say, hey, this is representing the number of cats. 5 cats. Well, first of all, we're not supposed to start with a number, but also a variable is used a lot of times because it can be changed. And so you wouldn't want to give a specific set of number of cats. Doesn't really make sense on what we're trying to utilize this variable for. So describe the value that it stores. So I've had students use random names for variables. And a lot of programs can be tens of thousands, hundreds of thousands, even millions of lines long. And so when you have programs that are that long, if you don't name your variables correctly, it can be very difficult to figure out what variables are what. And that goes for naming classes, naming methods, which we'll talk about later. But everything in your program should be descriptive because you're going to be programming on a much bigger scale in the professional world. So it's written in lower camel case. We save upper camel case for classes and some other things. But lower camel case for our variables, meaning you lowercase the first letter and then capitalize every additional letter, every additional first letter of each new word. So liter price. Here is how you would initialize a variable. You set a value equal to a number. And so now numcats has a value of 5. Oftentimes we'll see this as one longer line of code where you say int numcats equals 5 and you don't separate out into 2 lines, but you can do it either way. So the equal sign is not what you would traditionally see an equal sign in math of checking for equality. The equal sign is the assignment operator, so it assigns a value of 5 to the name numcats. Okay, so whenever you utilize numcats as a variable name later on in your code, it will be replaced essentially by the number 5 unless we change it later on, which we'll talk about. Okay, here if you try to print numcats and don't give it an initial value, and in this format this would be inside the main method, there would be an error. Okay, so variable numcats might not have been initialized. So we would need to give it an initial value before we utilized that variable. Food price, so here's written out all in one line, int food price equals 10.25. But this is not an integer value. If you figured it out, it's a double or a decimal value. So incompatible types, possible lossy conversion from double to int. So yeah, we're trying to convert an int. We're setting food price, which is an int, equal to a decimal. That doesn't work for the computer. So the type needs to match what the value actually is. So Boolean is asleep equals true. That's great. That works. The type, the name, the assignment operator, and then what the value it wants to start as. So in our computer, we're storing is asleep as a Boolean type variable, and the value inside of it is true. We can change is asleep to false. So if there was code in between these 2 lines, is asleep would be true at that point, but then once it reaches is asleep equals false, it updates. So once you, this is a good point. So once you assign a variable once to a data type, so Boolean is asleep, you do not utilize Boolean again. If you tried to, it would try to create a new variable which already is asleep already exists, so that would cause an error. So variable asleep is already defined and it would cause an issue. Final doesn't get used much in this course, but it is a way to identify something as a constant, meaning it cannot be changed after the fact. So this would cause an error, cannot assign a value to a final variable backpack price. So CodeHS has a part 2, but it's the exact same as part 1, so not any point of going through that again. This is an example. If you want to look through it, it can give you some information on how something works. You can run it and see what gets printed and see how that works, or reference back to it if you have questions. But we're going to go ahead and go on to the exercise problem. So you can explore int and double variables by working through tasks and questions below. Write the answers to the questions in the investigate.txt file. You can find the investigate.txt file in the left-hand panel. Click on the final name to open the file. Okay, so right away it says we want to predict before running the program what is supposed to happen. So it should print number of Snapchats sent, and it will print 353 on a separate line. Number of YouTube videos watched, it'll print this on a separate line, print this 400 on a separate line, and then print this on a separate line. So all of these should be just exactly what gets printed, but on separate lines. There doesn't seem to be any issues there. You can use to record your answers to the following questions below. Line 6, remove int so that the statement, I'm just going to talk through this. If we remove int from the statement Snapchat sent equals 353, we don't declare a variable type, so that would be an error. If we set it to 0.5, it would be possible lossy conversion, int converted to a double. Line 10, change the value to 130. So when we have a double, even though we put an int here, it will automatically convert that 130 to 130.0, and so that's what would get printed. So that is what would happen there. And then line 15, int to the beginning of the statement, so that is int Snapchat equals 400. Oh, Snapchat sent. So that would be, again, we saw in the notes how if we had two ints of the same, it would already be a variable that's declared, and that would also cause a syntax error. Okay, now create a variable to store the number of Instagram posts. Okay, a variable to store the number of Instagram posts. So number of account Insta posts equals, set it to 0. Print out an Instagram post label like, okay, number of Instagram posts, colon, it doesn't have a space, but I would put a space there and the others have a space. And then update the number of Instagram posts to 10. So Insta posts equals 10. And then, because we don't want to reuse the data type because we've already defined Insta posts as an int, print Insta posts, not in quotes, because we are printing the value, not the text. So that's important to see there. So I'm going to go ahead and check the code, but I think it wanted me to print this over again. Print number of Instagram posts 0, then update it, then print number of Instagram posts. So let me do copy and paste, and then copy, paste, oops, and then we'll check code again. Okay, looks a lot better. There we go. Submit. All right, and so we have our quiz. So which of the following accurately describes a variable to store the price of an item? Okay, so you want double and then price, the type, and the name. So that declares it. Which of the following is the proper way to declare it and initialize? So declare and initialize, type, name, assignment operator, and then the value. What are the memory values associated with the variables x, y, and z after the code snippet below executes? X holds a value of 7. No, it holds a value of 14. Okay, so one of these two. Y holds a value of 2.0. And z is true. So that would be this one, because at the end, z updates to true. Yes. Which of the following code segments correctly declares the initializes the variable num with the value of 5? This does, this does, this does not. Okay, you need to have a type. This has it all on one line, this has it in 2 lines, so 1 and 2. Consider the code segment below, declare it, but we don't print it. You can you have to declare a variable before using it. That's not the correct terminology. You have to initialize a variable before using it. Okay, and we'll talk about when you don't have to and it gives it default values, but that's a few lessons away. So main method, we have a final z, so we can't update it from the beginning, so compilation error. And it must know that since it's a constant, it must identify that z cannot update. So I was almost tricked there. So there we go. Now we're on to 1.2.6 signature. So in this exercise, you'll use variables and print statements to create a signature. Okay, initials. Create a variable to store your first name initial. So a variable to store first name initial, I believe, will be this. First initial equals t last equals 8 and day equals 14 semicolon and year equals 2025, and then we print. Nothing gets printed until we print. So we also, CodeHS is very particular. If this is what they want printed, you need to put that and not just the variable names. And I'm going to go ahead and copy paste so that I don't have to do this over and over again. 4, 5, 6, 7, I think. and then I'm going to print first init, and then I'm going to print last init, and then I'm going to print a blank line, then I'm going to print date, and then I'm going to print month, day, year. And then I'm going to run it, test it, make sure it looks good before I check the code. You know, on these easier ones, you can probably just go straight to checking the code, but in the future, you want to get used to running the code first to test your program to make sure it works correctly, and not just jump straight to checking the code, or you might. First of all, it helps prove that what you did correctly, and shows you, okay, this is actually what I expected to happen, and this is what happens, and that, you know, helps you remember, all right, this is why this works and what I did to make it work. And then checking the code, of course, checks that it's the right answer, but you don't really get that feedback that you want. And so, yeah, that is correct. Go to the next set of notes here. Reference data types and strings. All right, so yeah, we've talked about, like, if we wanted a whole name, you would not want to have to go one letter at a time, right? One character at a time. Is there a way to store an entire word or phrase in one variable? Yes, it's called a string. String is an ordered sequence of characters enclosed in double quotes. Okay, I am a string. So when we print hello world with double quotes, you are printing a string, and that's called a string literal, because it's a literal value. It's not a variable, it is the string value that you want printed. And so each position in a string, or each letter in a string has a position, or each character, even the spaces. Okay, so it's 0 through the end of the length of it minus 1, because we start at 0. So the L would be at location 0, the E would be at 0, 1, 2, 3, 4, 5, 6, 7. Okay, so all of those individual letters get stored in a box. So as opposed to the primitive types that just have one value, these reference types, which includes a string, have multiple values that it can store. Okay, so in the computer, it just stores that in a memory location, and then we can reference that memory location, which is why it's called a reference type as opposed to a primitive type. So a variable that stores an object, what we call an object, has a reference data type. It's just like your house has a memory address location, but this is not your actual house, it's just a location where your house is. So think of that with the computer. First programmer, name of that's your address. That's where the computer is going to find the value, your house, that it wants to retrieve. And so this is your address, but this is the actual value at that address. Type, same way we did with our primitive types. The type, however, it's capitalized because that signals that it's a reference type. So string, which is the name of a class, a string class, a pre-made class, and we'll talk more about that later. When creating a reference variable, the data type is capitalized, and then the name of the variable, and the assignment operator, and then the value, which is the double quotes. Okay, so pretty straightforward. We store it, we print it, there we go. We update it. You have to update it with an assignment operator, Bruno Mars. We print it again. Now it changes. Now, Taylor Swift doesn't just disappear. It goes into something we call string pool, which we'll talk about later. But Bruno Mars is what it's changed to, and that's what gets printed. So that is a string object. So Java is an object-oriented language that uses objects, which, like we said, are that reference, that box with multiple things in it, as opposed to the primitive types, objects and classes to organize the code. So we had talked about classes, the student class, the teacher class, the course class. String is one of those classes. A class is a container of code that groups together related data and actions. So remember, the student had a first name, last name, grade level, GPA, etc., etc. They could graduate to the next level. They could change their pathway. So many times when we have a class, you will create an object or an instance, sometimes we call it, of that class. And so when we have a student class, we're not just creating one student. That would be extremely inefficient code if we created a student class and we're only able to make one individual student. We create a student class so we can make, if there's 1,500 students at the school, you can make 1,500 student objects. So you wouldn't have to rewrite that student class code. You would just utilize it over and over again to create other students. So classes are often thought of as blueprints because they are templates for creating a specific type of object. So for the student example, we say when we create a student object, we need to have a first name, last name, grade level, GPA. They need to be able to do this, this, and this, graduate to the next level. Maybe they take a test. Whatever you need your code to do for your student, that's what you would put in the student class. Okay. So student name, student grade level, I could create an individual student object with a specific name, a specific grade level. I could change that student's grade and I could change that student's pathway. And it would not affect the other student objects. So I could create a Jamie Davis variable that is a student, which is an example of the student class. So I would create a student object that would look at the student class and be like, okay, if I'm creating a student object, I need to have this, this, and this in order for it to be a student. And I've written out those instructions or those details in the student class. So Jamie Davis we reference, and Jamie Davis has a few different things that it has stored: name, grade, pathway, change grade, change pathway. String class works the same way. String object, however, has just one list of characters. So it's really one attribute, but it's a list. So that one attribute holds multiple characters. And then the string class also has methods that they have pre-written for us, because the string class is already pre-written in Java, that we will borrow and use to split up a word. Maybe you're trying to do a word count and count the number of words. Maybe you're doing a find and replace inside of a string, so you need to write code to find a specific word. That is called substring, is one of the methods in there, or .contains. There's a few different methods that we will utilize from the string class that are very important for this course. So something we'll use a lot. Okay. So this is a quick example of how strings are utilized, printing them out just basically, but how they look getting initialized and then getting printed. But you could take a look at that if you need to, but we're going to move on to this quiz. So choose the data type that would be most appropriate to store the number of students in a school. So number of students would be a count. You can't have half a student, so that would be an int. The name of a student, string. A student's GPA, decimal, double. Whether or not a student enrolled, true or false, Boolean. Which of the choices below is not a primitive type? So string is a reference type. Talked all about that. Int crayons. So number, whole number, integer. Describes characteristics of reference data types. They hold their values directly in memory? No. They hold a reference, remember the home address, which sends them to the actual home, which is the actual value. They hold information about an object's location in memory. Yes. They always hold numeric primitive types. No. So it looks like 2 only would be our answer. There we go. This exercise is similar to earlier signature, except this time you can use strings to write a program that prints a more official signature. Name, Ada Lovelace, date. Yeah. All right. So string, I'm not even looking at what the actual instructions are, but I'm hoping that I'm right. Last name, and then string date. I know there are numbers in there, but it's a comma and spaces and multiple numbers. So it would be, I think they wrote out August 14th, 2025. Let's look at the assignment to make sure. August 10th, 1842. They want those other things also printed. Okay, triple click, copy, paste, 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 paste. That's 5, perfect. Name, colon, first name, last name, quote, date, colon, and then date. And maybe current date would be a better name for it, but that works too. So I believe that's exactly what they want there. Created 3 variables, added labels to output, printed appropriate output. Beautiful. Okay. (1.2.11) Declare and initialize variables for each scenario. A friend's name. String friend name equals Jimmy. My lucky number. Int lucky num equals 7. Whether or not you are a morning person. Boolean morning person equals true. And then my favorite snack, string fave snack equals PBJ. Is that a snack? I don't know. Price of my favorite snack. Double price equals, probably should be more descriptive than that, but 225. Let's just say, print out each variable, system.out.println. Copy 1, 2, 3, 4, 5 different variables. Command C, Command V, or if you're on PC, Control C, Control V. Get used to using these keystrokes. It will dramatically increase your speed on these problems here. So boom, boom, boom. Hopefully that's what they wanted. I think so. Did they want me to use those actual values? I hope not. That would be not ideal. Hey, no, they don't care. Cool. All right, 1.2.12. This is a swapping one. I don't love these because it's just not entirely practical, but it does teach you something here. So what do you think we'll have on the program run? So 1 equals 2 and 2 equals 1. Well, when we do this, and this actually is utilized in the course. So swapping, if you try to update a value and then it is updated on this line. So if I'm setting 2 equal to 1, well, 1 already was set to 2. So value 1 is actually value 2 at this line. So then value 2 equals 1. Well, they're both value 2 now because 1 already got updated, and then it updates to what it already is. So that is what I predict will be printed. Value 2, you see down here. Okay, yes. So common technique. Okay, yeah, you create a temp value. String temp equals, you set that to the original. Then you update the original, which is 1, and then you assign 2 equal to temp because it has already been stored as the original of 1, which is what we want. So we do this. Now value 2, value 1, they're swapped. So I'm not sure what else they want us to do. Investigate, what are the values of 1, 2, and temp on line 14? Okay, so temp is 1, 1 is still 1, 2 is still 2. On line 15, temp is 1, 1 is 2, 2 is still 2. And then line 16 is when they're all updated and these two are swapped. So there we are there. Great job. Oh, team rank. I love this one. Okay, so 1 through 6, you print them. We need to update so that keep the team name variables exactly as they are. Declare, don't rename them. Use assignment statements to swap the values stored in those variables until the print out shows the new order you want. See new order. Okay, new order. So 1 through 6. So Ohio State needs to swap with Penn State. So how do you do that? You create a temp, I'm going to call it temp1 equals team1. No, team1 stays the same. Team2 equals team6. So team2 updates. So team2 is now Penn State. And then team 6 needs to update to Ohio State, which is can't be team 2 because it's already updated to team 6, so it has to be temp 1. So we do that all over again. You really can use temp 1 again and say temp 1 now equals whatever we want to update next, which is team 3. Team 3 equals what? Clemson. So that would be team 5. And then team 5 equals now temp 1 has been changed to team 3. So swap 2. Swap 1. Is there any other swaps? Florida State, USC. But Florida State already swapped with Clemson. So Florida State is team 5. Swap 3. So Florida State is team 5, but it needs to be team 4. So USC and Florida State need to swap. So team 4 and team 5 need to swap. Temp 1 equals team 4. Team 4 equals team 5, because that's now where Florida State is. Team 5 equals temp 1. I know this is confusing. That's why I said I don't love this problem, but it gets the idea of swapping. Correct. So Alabama, Penn State, Clemson, Florida State, USC, Ohio State. Alabama, Penn State, Clemson, Florida State. Yeah, I think that's right. So check our code here. Print output matches the desired new team order. Great. Beautiful. Perfect. All right, 1.2.13. So that is it for 1.2, and we'll continue on to 1.3 in the next video.